Now, the variable region, it is the region which is responsible for antigen binding, because it is at the top. The constant region are the responsible for various biological functions. Main important thing is the complement activation and binding to the receptor. Binding to the receptor. What is the role of the variable region? It binds to the antigen. Epitope of the antigen. And what is the function of the constant region? Two function majorly. Number one, complement activation. Number two, receptor binding. Now at the site FAB fragment, this is the antigen binding site, and FC, which is a crystallized fragment, it is a complement fixation. It also do opsonization. It can attach with the placentals and it can cause the mucosal attachments. So complement activation, IgM and IgG. Opsonization, immunoglobulin G. Placental attachment, immunoglobulin G. And mucosal attachment, immunoglobulin A. All these are done by this FC region. FC region is the region of the heavy chain or light chain? You gentlemen with the cap. Heavy chain or light chain? FC region is the region which is present in the heavy chain or light chain? Heavy chain. It is heavy. And binding to the mast cells, IgE. Here, FAB region, this is FC region. You can break this antibodies by this hinge region. If you want to break it, it will be broken into two portions, FAB and FC region. Now this is the immune response. It comes and binds. This antibody will only bind to this one. It cannot bind with this one. It can't bind with this one. It cannot bind with this one. Because there is a morphological similarity. Shape are similar. Which theory is this one? Lock and key hypothesis. Very good. Lock and key theory. This is a lock and key theory. There is a picture and we'll fix in it. Okay. What is the other theory beside lock and key theory? Let me ask somebody who is very intelligent. Let me see somebody, leader, who is more intelligent. You know what is lock and key theory?
No.
Huh?
No.
Huh? Really?
Yes.
Okay. You know what is lock and key theory? Lock and key hypothesis. Yes. You know what is lock and key hypothesis? Huh? No. Yes, Ghazali. Lock and key hypothesis. Maafi malum? Yes, you.
What's the question?
What is lock and key hypothesis? This, you know, this Majdi, it creates problem for you. It creates always problem for you. What is lock and key hypothesis? Nala. Yes. What is lock and key hypothesis?
I'm not sure.
Huh? You should sit on the front, tamam? Yes, what is lock and key hypothesis?
Maybe it's like what you took before in pathology.
Yeah, maafi pathology. Yes. Ya Allah. Yes, Ghali. Lock and key hypothesis. Excellent. Lock and key hypothesis is this hypothesis where this morphological similarities will come and attach to it. If they are not same, they will not come in it. What is the other theory? Induced fit hypothesis. Induced fit hypothesis. These hypotheses are in the enzyme actions. So here similarity, you can see this structure is here and it will bind with this one. It cannot bind with this one. Why it cannot bind with this one? Different shape. Can it fix in it? It cannot be fixed in it. Clear? Okay, so immunoglobulin have 5 types and each type have different types of the heavy chains, and these are designated by alpha, by gamma, alpha, delta, mu and epsilon. And we have 5 types of the immunoglobulins as we mentioned Majid. So gamma heavy chains, alpha heavy chains, mu heavy chains, delta heavy chains, and epsilon heavy chains. IgE, why we call it IgE? Because he has heavy chain epsilon. Why we call it IgA? Because it has alpha heavy chains. Why we call it IgM? Because it has mu heavy chains. These are the heavy chains: molecular weight, serum level, and half-life. Now, few important things. These are very important. Here you can see IgM, guys. IgM, mu chains, molecular weight 970 and serum level 1.5 milligram per ml, and half life is 10 days. Tamam. IgD, delta chain 184.03 and 3 days. IgG kullo, if you combine all these IgG, their life is 146, 146, 165, 165, less than this one. And even if you combine the whole days, it's almost 20 days. So for long duration, they stay for long duration. And even their level are too much than this one. IgA, Ig2, if you combine this, is almost 160 and again 6 days. And IgE 188 days and 2 days duration. Tamam? Which one is the, okay. If you see the function, IgM, it causes neutralization, it can't do opsonization, it cannot do sensitization or killing, even mast cell, no, but it activates the complement system. Too much activation of the complement system. If you see IgD, do nothing, we don't know. If you combine this IgG, it do all the function. Neutralization, yes. Some of them they do opsonization, yes. Some of do they kill directly, yes. Very weak mast cell activation, yes. But again they can do mass activation of the complement system, yes. IgA, again the neutralization is there, opsonization is weak and rest are weak. And IgE, it can activate the mast cell too much. Allergy. Activation of the mast cell too much. Now, here the antigen, interleukins, and formomin cell. Again the same response, first response and the secondary response is fast because the memory cell will make the cells. Memory cell will make. Now to the quickly to all these 5. Now if you see here, which one is the heavy? IgM. When there is a fight, when there is a two groups, group A and group B, fight between group A and group B. Tamam? You know, in old days, how was the fight? When there are one group here and another group here, how the fight starts? 1-1 first, huh? So from group A, who are the group A? Raise your hand. Group A, only 4 guys? Huh? Oh, who you will send first? Who you? You cannot. Huh? The leader is yes. Okay. And what about the group B?
Group B.
Who you will send first? Where is Talal? This this one. That one is okay. The two heavy one, let them do what they do. They might decide each other. Khalli wali, maafi mushkil. Let's go in McDonald's, maafi fight. It's possible, you know. In the middle of the ground, they say, yalla, khalli wali. Let's go to McDonald's, leave them. My point is that when there is a fight, when their antigens are there, the first antibody that comes, Ghaznavi, this one is a heavy one. Now see quickly them. This is IgG, predominant immunoglobulin, highest number. Serum antibodies level is 75 to 80%. It can come in the present in the blood, lymph, intestine, peritoneal and cerebrospinal fluid. All these are very important information. Huh? Synthesized at a high rate, half-life almost 23 days, complement fixation yes, placental transfer yes. So from mother to baby, IgG. IgG. Tamam? Here it is two molecule, two chains, two chain, one chain and second chain. Simple 1 2 3 4 1 2 3 4 1 2 1 2. Clear? What is this site? Complement binding site. What is this region? What is this region? FAB region, antigen binding site. Tamam? So selection of the IgG subclass by particular immune cells depending upon the human, depending upon their activities against the polysaccharides which are present in the IgG or Ig2. They are immunogens and they are skewed towards the IgG and IgM. So with some of them they are more in Ig1, some of them they are more in Ig2, and depending upon their function there are different types, Ig1, Ig3, Ig4. So if you see the action, if you see the complement pathway action, Ig3 have more action than G1 and it has more action than G2 and G2 has more action than G4. Clear? Depending upon their capacity. IgG has Fc receptors and they bind with the complement. So binder of the immunoglobulin and macrophage, polymorphs and lymphocytes. And their interaction, very important, with the receptor, they cause many functional effects including phagocytes, antibody dependent cells. The mechanism is called antibody dependent cell cytotoxicity, ADCC, and they ultimately kill the antigen. And specifically for the ADCC, Ig3 is more than, Ig1 is more than 3 and 3 is more than 2 and 2 is more than. So they have a good ADCC, antibody dependent cell cytotoxicity. So here, this is, what is this? Antigen on the cell surface of the bacteria. This is the like for example phagocytic cell, and this is the complement in between. Shuf, this is the complement in between. So what complement is doing? What antibody is doing? Sorry, this is the antibody is between. What antibody is doing? On the one side it is attached to the bacteria, and on the other side it is attached to the cell. So this is called antibody, this is antibody, tamam, dependent cell cytotoxicity, ADCC, ADCC, cytotoxicity, killing of the cells, killing of the cell. Clear? Okay. For example, you know Messi, huh? Messi come in the shaving cream, tamam, in the ad is doing goal and then is coming in the ad of the shaving cream, tamam. This is a shaving cream which is making by the company, and who will bought this? Shabab will bought it. Where is the Messi in between?
In the crane.
Tamam, is connecting the company with the Shabab, isn't it? So this is Messi, huh? Shubhada. This is Messi, this is shaving cream, this is Shabab. It's called antibody dependent cell cytotoxicity. Tamam? Okay guys, so this is IgG. IgM pentamer, pentamer, 5 components, 5 to 10%, serum half-life is 5 days, and this is the pentamer. That's why its complement activation is very fast, very too much, connect with too many constituents. Tamam? And this is the first antigen that come, this is the first antibody that come to the action. The two most common forms of IgMs are membrane bound, monomeric form, and secreted the pentamers, and it comes very quickly. So the role of secretory immunoglobulin IgM not only in the humoral agent primary immune response, but also like IgA is transported across the epithelial cell and serve as the role of the secretory immunoglobulin and mucosal surface and in the breast milk. Although it is a big molecule, although it is a big molecule. So Okay guys, IgA dimer, IgA dimer, two copies are there, but 2 copies of 4 chains, 1 2 3 4 1 2 1 2 3 4 1 2. So it is a dimer. The majority of the IgA is synthesized in the secretory form, large function of the IgA plasma cell residing on the subepithelial cells, secretions, all the secretions. The first line of the defense against the organism that would invade the mucosal route. So whenever it comes to the mouth and the eyes, IgA will come first. IgD monomeric like IgG. One more thing, if you go here, I will show you something. In the IgM, although it's pentameric and it has 1 2 3 4 5, tamam, 4 heavy chain, 4 constant chain, 1 variable chain. Rest of the all other have 4 regions, 3 constant and 1 variable, tamam, 3 constant and 1 variable. So that's why, because it's heavy, IgD is monomer, very less, 0.2%, and function is not known. And IgE again is monomer, very low area, and serum immune life is only 2 days, and it is very much important for the allergic reactions. Now, the last component, yes please.
What is the most important thing that we should know from each type?
Each types? Their function, their structure, their binding, all the two whole tables. Why do antibody need an Fc region? Because the FAB fragment can detect antigen, precipitate antigen, block the active site of the toxins, and block the interaction between the host and the molecules. But it cannot activate the complement and inflammatory response. That's why you need Fc region. The complement system is a very strong system. Complement. You know complement. Complement means to support. So there are how many systems are there? One is the WBC systems, primary response, secondary response, and in addition to all these, there is a complement system which can help in so many things. Opsonization, again it helps in the opsonization, neutralization, and direct killing of the organism. So now what we have done, these are the genetics. Anybody who is interested in this, read it, it's very good, go home and read it, okay. Now what we have done, these all are the genetics, but I am not going into the detail of this one. Even you can calculate the number of the possible antibodies, light chain and heavy chain, how it will make. Now what we have covered in 2 sessions. In session number 1 we covered the types of the antibodies, the mechanism, the types of the immunity. In section number 2 we covered the different types of the antibodies, their structure, their functions, their characteristics, and their response. Clear? We expect from you that you should know these 2 things, because once we move forward, when we go to the complement system and we go to the primary and secondary response, you will remember all these, and you will come and go again and again and again. Try to understand the concept of the MHC. I told you that there are 2 types of the MHC, one is 1 and one is 2, and they are called major histocompatibility complexes, and we discussed the function of one, that what is the role there, that they are the presenting cells. So whenever the antigen comes, it's broken down into the pieces, and that small piece is attached to that MHC, and MHC show it to the others. Clear? Any question? Attendance sheet. Thank you very much. I hope